지금부터 2024년 제1회 학습과학연구소 심포지엄을 개최하도록 하겠습니다. 이번 심포지엄의 주제는 우리 다 관심 많으시죠? 생성형 AI 시대의 교육의 미래입니다. 저는 심포지엄 사회를 맡은 서울대학교 사범대학 교육학과의 이경미 교수라고 합니다. 오늘 행사는 개회사, 축사, 강연, 기념 촬영의 순서대로 진행되도록 하겠습니다. 그럼 지금부터 심포지엄의 첫 순서로 서울대학교 학습과학연구소장이신 조영환 교수님께서 인사 말씀을 해주도록 하겠습니다. 큰 박수로 맞이해 주시기 바랍니다.
예, 안녕하세요. 서울대학교 교육학과에 있는 조영환입니다. 제가 이제 작년부터 학습과학연구소장을 맡고 있습니다. 오늘 이렇게 추운 날씨에 많은 분들이 참여해 주셔서 감사드립니다. 어, 오늘 이제 새해 초가 되면 누구나 이제 새해 무엇을 할지 그런 것들 좀 고민하게 되잖아요. 네, 저는 이제 올해 해돋이를 보지는 못했지만 갑진년에 우리 학습과학연구소가 더 한 단계 더 발전하기를 많은 소원을 빌었습니다. 그래서 학습과학연구소에 대해서 제가 간단하게 좀 설명을 드리면 저희가 이제 2022년부터 학습과학연구소를 준비를 하였습니다. 그리고 작년 9월에 여기 계신 이제 학장님과 여러 교수님들이 또 도움을 주셔서 성공리에 학습과학연구소가 개소하게 되었습니다. 그래서 학습과학연구소는 어, 그 다양한 분야의 연구자들이 같이 모여서 학습에 대한 융복합 연구를 하는 것을 목표로 하고 있습니다. 그래서 앞으로 학습과학연구소가 많이 발전할 수 있기를 바라고요. 올해는 이제 학습과학연구소가 이제 좀 이제 아기로 치면 이제 작년에 이제 태어났으니까 이제 좀 올해부터는 좀 이제 기어 다니고 또 걸어 다니고 하는 그 기초를 쌓아야 되는 그런 시기라고 여겨집니다. 지난해 이제 한 10분 정도의 교수님들께서 운영위원회에 참여해 주셨고, 올해 3월에는 견무연구원이 한 40분 정도가 참여해 주실 계획입니다. 그래서 사범대뿐만 아니라 여러 단과대에서 우리 학습과학연구소에 많은 관심을 보이시고 계십니다. 그래서 올해는 이제 여러 가지 또 이지라든지 아이 트래커와 같은 여러 연구 장비들도 좀 구비를 해서 기초적인 연구들을 많이 하고자 합니다. 학습과학연구소의 가장 중요한 주제 중에 하나가 AI 기반 교육입니다. 그래서 생성형 AI 시대의 교육의 미래라는 주제로 오늘 심포지엄을 개최하게 되었습니다. 역사적으로 우리가 테크놀로지가 발달할 때마다 학생 중심의 맞춤형 교육에 대한 기대가 굉장히 높았습니다. 그런데 그때마다 또 그게 이제 성공적으로 이루어지지 못한 경우가 많이 있었죠. 그래서 지금 생성형 AI가 작년에 도입되고 나서도 굉장히 이제 큰 기대와 또 그거에 대한 우려가 같이 공존하고 있는 상황인 것 같습니다. 그래서 앞으로 학습과학연구소에서 이런 생성형 AI가 어떻게 우리 교육에 영향을 미치는지 또 생성형 AI를 기반으로 해서 어떤 미래 교육을 만들어 가야 하는지에 대한 깊이 있고 심도 깊은 그런 연구들을 많이 하고자 하고 계획을 세우고 있습니다. 그런 점에서 오늘 심포지움에서는 미국 펜실베니아 대학에 계신 님과 또 영국 UCL에서 오신 무트루 쿠크로바 교수님을 모시고 생성형 AI가 우리 교육에 어떤 의미를 가지는지 다 같이 살펴보는 좋은 기회가 될 것 같습니다. 어, 이 두 분은 그 우리가 인공지능 기반 교육 또 데이터 교육 데이터 과학 이런 분야에서 굉장히 저명하신 두 분을 초청하였습니다. 오늘 이 심포지엄을 통해서 인공지능 기반 교육과 미래 교육 혁신에 대한 논의가 더 활발하게 이루어지고 또 학습과학연구소가 이제 글로벌 학습과학 연구의 플랫폼이 되는 계기가 되기를 희망합니다. 해외에서 서울대를 직접 방문해 주신 두 교수님과 또 온라인과 오프라인에서 지금 참여해 주고 계신 많은 교수님과 학생분들에게 다시 한번 감사를 드리면서 개회사를 마치고자 합니다. 예, 감사합니다.
네, 감사합니다. 또 개회사를 들으니까 더 또 오늘 세션에 대해서 기대가 되는데요. 다음으로 저희가 또 강연자분들을 모시기 전에 사범대학교 학장님이신 강준호 교수님께서 축사를 해주시겠습니다. 모두 큰 박수로 학장님을 맞아주시기 바랍니다.
안녕하세요. 아, 서울대학교 사범대학 학장 강준호입니다. 먼저 굉장히 이렇게 뜻깊은 시간에 여러분들을 뵐 수 있게 돼서 정말 기쁩니다. 오늘 이 자리는 학습과학연구소가 지금 소리 나오나요? 학습과학연구소가 작년에 개소식을 하고 실질적으로 처음으로 심포지엄을 여는 그런 날입니다. 그래서 저는 개인적으로 굉장히 감개무량하고요. 특히 오늘 이 자리에는 학습과학을 연구하는 세계적인 그런 교수님 두 분을 저희가 모실 수 있게 되었습니다. 라이언 베이커하고 그다음에 무틀루 쿠크로바 교수님이십니다. 유니버시티 오브 펜실베니아와 유니버시티 오브 칼리지 런던, 미국과 영국에서 학습과학을 선도하고 있는 분인데요. 오늘 보시면 그 주제들이 상당히 흥미롭습니다. 여러분들 인류가 지금 인공지능 시대, 특히 생성형 인공지능 때문에 인공지능이 현실로 갑자기 다가왔습니다. 인류가 지금 적응하느라고 정신이 없는데 불과 1년이 지났는데 저희는 전부 AI에 맞춰서 온 분야와 생활들이 적응하느라 정신이 없죠. AI가 가장 큰 영향을 미치는 분야 중에 하나가 교육일 것입니다. 우리 챗GPT가 2023년에 나오고 또 얼마 전에 구글에서 제미나이가 나왔습니다. 제미나이는 특히 멀티모달 AI를 다루는 인공지능인데 우리 교육에는 특별한 함의가 있는 굉장히 도움이 될 수도 있고 또 위협이 될 수도 있는 그런 인공지능이 출현했습니다. 인공지능으로 인해서 사실 저희가 획일화된 그런 교육에서 맞춤형 교육으로 전환할 수 있는 정말 실질적인 수단을 저희가 확보하게 되었고 그 과정에서 많은 의미 있는 연구들을 이제 해야 합니다. 생성형 인공지능의 역할, 또 그것이 교육에 미치는 영향, 긍정적인 영향, 부정적인 영향, 그리고 또 인공지능이 우리 전인 교육에 어떻게 활용될 수 있는지 등등에 대해서 정말 근본에서부터 최첨단의 응용에 이르기까지 다양한 문제들을 고민을 해야 되는데 이 두 분은 그런 의미에서 굉장히 좋은 연구들을 하고 계십니다. 라이언 베이커께서는 교수님께서는 소위 이 대규모 언어 모델이 교육 분야에서 어떻게 활용될 수 있는지를 오랫동안 연구를 선도적으로 해오셨습니다. 그래서 Penn Center for Learning Analytics라고 하는 학습 데이터 분석 센터를 오랫동안 운영하시고 계시고요. 그다음에 우리 쿠클로바 교수님께서는 AI 생성형 인공지능으로 인해서 혹시 밀려나게 될지도 모르는 교사의 역할이라든가 또 인간과 인간이 서로 상호작용할 때의 그런 중요성 그리고 AI와 교사의 역할에 어떻게 균형을 맞출 수 있을지 등에 대해서 훨씬 더 성찰적으로 강연을 해주실 그럴 예정입니다. 그래서 오늘 굉장히 좋은 두 분을 모셨기 때문에 저희 사범대학뿐만 아니라 인공지능과 교육에 대해서 관심이 많은 학내의 많은 분들께서 이 자리에 참여하고 계신 걸로 알고 있습니다. 다시 한번 멀리서 날아와 주신 우리 두 교수님께 진심으로 감사드리고 오늘 이 자리를 통해서 생성형 인공지능이 우리 미래 교육에 어떤 영향을 미칠지 진지하게 고민하는 자리가 되었으면 합니다. 고맙습니다.
오늘 행사를 위해서 다시 한번 우리 라이언 베이커 교수님과 그리고 무틀루 쿠크로바 교수님께서 참석해 주셨습니다. 저도 사실 아티클로만 만나뵙고 또 유튜브 동영상으로 만나뵙던 분들을 이렇게 실제로 보니까 약간 설레기도 하고 그런데 여러분들도 이분들이 우리에게 어떤 메시지를 주실지 되게 궁금하실 것 같아요. 그래서 이분들의 특징은 사실 AI 연구를 사실 여러분이 우리가 생성형 AI가 나오기 이전부터 오랫동안 하신 분들이에요. 저희는 지금 챗GPT 때문에 막 AI가 새로 떠오른다고 생각하지만 사실 이분들은 지난 10년간 AI 관련 연구를 많이 하셨고요. 그래서 그분을 그 부분을 염두에 두고 또 강의를 들어주셨으면 좋겠습니다. 그래서 이분들은 사실 우리가 흔히 얘기하는 뭐 너무 신나는 미래에 대한 얘기보다는 실용적으로 어떻게 생성형 AI를 활용해서 사용할 수 있을까? 또 비판적으로 교육 현장에 이런 생성형 AI가 들어오면 어떠한 문제점이 있을까? 그래서 저희가 좀 약간 가려웠던 부분을 너무너무 신나게 또 잘 긁어주실 거라고 저는 개인적으로 기대하고요. 그러면 네, 첫 번째 강연자 라이언 베이커 교수님을 소개하도록 하겠습니다. 아까 잘 소개됐지만 라이언 베이커 교수님께서는 유니버시티 펜실베니아에서 재직하고 계시고요. 또 인터내셔널 에듀케이셔널 데이터 마이닝 소사이어티라는 학회를 직접 만드시고 초대 학회장을 역임하실 정도로 러닝 애널리틱에 관심이 많으셨습니다. 현재는 펜 센터 for 러닝 애널리틱의 책임자로도 활동하시면서 다양한 저작 많이 하고 계시는데요. 오늘 심포지엄에서는 대규모 언어 모델을 활용한 교육 연구 사례를 직접 연구하신 사례를 공유해 주시고 미래 교육에서 인공지능을 어떻게 활용해야지 학습자에게 더 맞춤형으로 좋은 교육을 제공할지에 대해서 논의해 주실 예정입니다. 그러면 우리 크게 라이언 베이커 교수님을 큰 박수로 환영해 주시기 바랍니다.
초대해 주셔서 고맙습니다. 수북해 오늘 저는 한국어로 못해요. 못 강의해요. 아직 공부해요. 그런데 아직 안 잘해요. 그래서 영어로 할 거예요. So today I will talk about recent work on large language models in education at the Penn Center for Learning Analytics. So I guess I've already been introduced, so I don't need to introduce myself. Thank you for the kind words of welcome. So I'll introduce my center a little bit. By the way, the Penn Center for Learning Analytics uses a blend of large-scale and small-scale research methods from analytics, data mining, and foundation models like large language models to ethnographic and field observation methods to study learning and engagement. And we conduct research on both state-of-the-art learning and online learning environments and traditional classroom instruction, investigating what approaches and methods can best enhance student long-term outcomes. In the last year, really, year and a half, large language models have exploded onto the world, and sometimes it seems like they can do anything. Here's a message I put in just the other day. I'm a monkey from Dallas, Texas. My wife is a squirrel from Ulsan, Korea. Please recommend some 5th anniversary guests that represent our unique relationship and identity, and make some thoughtful suggestions for us. I use GPT all the time. Who here uses GPT a lot? Yeah, most of the room, right? It's amazing. I didn't use it that much during the holidays, so I feel like this isn't quite as true as most of the year, but I use it all the time during the semester to obtain quick summaries on topics I don't know well, to write Python code for simple functions where I don't remember the operators off the top of my head. Used to be it was faster to ask my students to program. Now it's just faster to do it myself. Fixing colleagues' grammar and writing clarity in joint research articles. Practicing my Korean conversational skills. First drafting tenure letters. I write a lot of those these days, unfortunately. Writing bedtime stories for my 4-year-old. Optimizing my workout routine and getting better answers on cooking questions than just from the open web. So for all kinds of stuff. And we use ChatGPT a bunch in our research too. And fair warning, this talks about recent work on large language models in education at the Penn Center for Learning Analytics. There's lots of other folks doing great stuff, but there's just not time to talk about all the great stuff out there. Conmigo, who are partners of ours, have this great dialogue-based tutor they deliver to middle school and high school kids. We've had the honor of working with them. They're great. Andrew Land's group has been doing amazing work personalizing to student interest. North Carolina State folks have been doing categorization of course grade student responses. Sysmans has been doing automated generation hints. There's so much going on. It's such an exciting moment. And with the main conference submissions coming up in the next month, I'm really excited to get the first crack at seeing what else everyone's doing. I'm going to start first with talking about everyday usage and everyday utility we find. In a room that's got people using it as much as here, maybe I'm just telling you things you already know, but hopefully there's a thing or two that's interesting to some folks. So, as mentioned, I use ChatGPT to summarize complex topics. And that can be really neat for when there's somebody in the lab who wants a quick explanation of something, or when I need a quick explanation of something I haven't looked at lately. And it also can be very good at doing that, especially if you give it a little bit of help with One of the common strategies, which I think I might talk about in a minute, clumsy, tulangdeo, is praise and prompt, where I don't just ask it for an explanation. I tell it it's a college professor known for its excellent, clear explanations. And I tell it I'm an undergraduate struggling to understand. And that changes the kind of explanation it gives, which is pretty amazing. Also use it a lot in our lab for adapting content to specific audiences. We often build instruments for middle school students or younger. And there's a lot of work involved in doing that. And so we have to often do multiple rounds of co-design with students. ChatGPT helps us skip the first round of co-design. So we still do co-design with students, but we do less. We also, as mentioned, use it to help us program. And recently, I developed a game in JavaScript using GPT, which was particularly impressive to me because I don't program in JavaScript. And it works. We also use it sometimes to help us brainstorm paper titles. And we use it a lot to help us improve our writing. Writing in English is hard. Writing in any language is hard. And we have a lot of members of our center who aren't native speakers. And they put their stuff into ChatGPT paragraph by paragraph, and it clears up the mistakes, improves the clarity. We have one second-year student in our lab who, when he joined us, his writing actually was at a point where I couldn't figure out what he was trying to say. And now what he does is he runs it through ChatGPT first, and then I'm able to give him feedback on the ideas rather than getting caught up in trying to understand it. Beyond these forms of mundane utility, though, we use it a lot in our research, more directly. For example, for qualitative coding and text classification. Who here does qualitative coding at all? A couple folks, a few folks. So we published our first paper on this last fall at the International Conference on Quantitative Ethnography. That's work by Andres Zambrano. The data here is from Joyce Zhang. So we give it a definition, and then we tell it to code it 1 if the definition is present and 0 if it's not, and we give it to it to code. It's that simple. There's been a little bit of back and forth on getting the prompts designed, and but how it does almost as well as Encoder Plus, which is a much more labor-intensive tool to use for automated text coding. With Encoder Plus, there's like all these rounds back and forth, and with this, literally 0 shot, we can get it to work this well. But performance isn't the whole story, because it isn't yet as good for our purposes, and we've done some playing with it. We have not yet gotten it to be as good as Encoder Plus, for example, for getting recall of the constructs we want. But more importantly, it helps us refine our code books, even for human coding. So we can, after it makes a mistake, we can say, well, I consider this to be this category. Can you explain yourself? And then it can actually help us rewrite our code book so that our code book is even more easily usable between human beings, which is kind of a much more powerful thing than just being able to code. So we use it to refine our code books. We also give it cases where human coders disagree with each other and ask it why they disagreed. And it can give hypotheses for that, which can be much faster than going back to those original coders and trying to figure it out. So we're currently doing a project to figure out whether the refined code books lead to better human-human coding. We're going to be submitting it in hopefully 2 weeks, although it feels like the lab hasn't gotten much work done over the holidays. But we've taken a whole spectrum of human-human coding to computer human coding, with kind of stages in between of humans refining computerized code books, computers refining human-developed code books, and computers suggesting new coding categories. And we're going to investigate the relative quality of human and computer coding in this spectrum of possibilities, which at the far end, with the computer suggesting the codes in the first place, the computer helping humans refine their coding really kind of gets a lot faster than traditional qualitative coding, with, as far as we can tell, low quality. We've also been working on auto generation of short answers. So our big goal is to recognize human answers in various categories in a biology learning platform, even for very rare categories. So those of you who've done automated classification of text know that sometimes you want to classify things that are very rare. And that doesn't work so well if you can't get enough human examples. But you can have GPT create your examples. So our goal has been to create synthetic examples that can be used to train an algorithm to recognize the categories that we want to recognize. The process is we give ChatGPT the examples we have. And by the way, I say ChatGPT because right now ChatGPT 4 remains the best for all its flaws. We are eagerly waiting for Llama or Claude to get good enough that we can use it the same way so that we can have more control over what we do. But we give it the examples we have. We ask it to create 30 new examples. Humans check them. And then we ask it to create 30 more examples based on the initial prompt that meet a criterion. Check those. And then we give it those examples, ask it to grade student work. Here's our prompt. I'm an explanation generation bot. I'm trying to generate this type of explanations for the graph I've chosen. Now I'll generate 30 examples. I'll make the sentence structures of the examples as various as possible. If you don't do that, it gives you very similar examples. And I should not use words like while or whereas. So in our initial draft, we found that it was giving us very formal language, much more formal than a regular student would use. And we found that just asking it to be informal didn't give us what we wanted. It got too informal. But if we found words that it gave us that regular students don't use and said, don't use these words, it intuited the broader category better than just telling it. This is somewhat of the arcana that large language model usage still is today. And it in fact produced legitimate looking explanations. They look very much like regular student explanations. It did not lead to better performance than it did not lead to better performance than just human data. But why this is valuable is because sometimes we don't have human data. We find that if you have no human data whatsoever, it doesn't do very well. But if you have even 10 cases, sorry, if you have even a small number of cases of human with more synthetic data, it works fine. Another category of usage we've had is learning support. We have a teaching assistant, GPTA, at Penn. And GPTA goes on our discussion forums and answers student questions like a human TA. It's not the only large language model TA piloted this fall. There's one at Harvard as well. There's others popping up now. It can do various things like answer conceptual questions about the assignment. Student has a conceptual question, it gives an answer and a correct one. It can help students thinking through their work on assignments. In this case, the student is looking at the data set, and we've given GPT information about the assignments and past semester's postings, and it can answer questions about the data set and the assignments. All the posts are approved and occasionally not approved by the professional and human TAs. This next semester, we're going to have some cases where it goes straight to the student without being checked. The first semester, we wanted to check everything, and we're glad we did. It got a few things wrong here and there. Now, how fast is it? Well, it's not obviously as fast as if it responded immediately, but still, writing a long post would be a pain for our human TAs and instructors at 2 in the morning. It's much easier. I get up early, my TAs stay up late, and we can very quickly say, yes, this post goes through, or you can wait till morning. Sometimes it goes off the rails. It tried to pick an argument with one of our TAs where when her office hours were offered. So the TA said she was going to offer office hours on Friday afternoon, and GPTA wanted to argue with her and say that's a bad time to offer them. So we suppressed that. So does it work? Not every response is perfect. We don't always use its recommended posts. It saves me and the TAs a lot of time and provides much faster responses to students, on the average of a couple hours as opposed to a day or two. We collected data last semester on student attitudes pre-post. We're analyzing it now. It actually turns out that students think it's about equally as good as a human TA, which our grad student analyzing was like, oh no, they think it's only as good as a human TA, but I actually think that's amazing. Like it was not different from equal. We didn't look for learning gains from its first use because really all it's doing is providing faster feedback. This semester, it's more of a convenience for everybody than providing something we couldn't otherwise provide. But next semester, what we're going to do, we've trained it with all of my grading from last semester, from the last 3 years for the class. And when students turn in their assignments, they're going to get an automated grade from me, from GPTA. that they're then going to have a chance to revise their assignment based on before it ever gets to me or the TA. And we think that that will actually be quite beneficial to students because they'll get kind of feedback to be able to iterate and learn from much faster, almost instantaneously, and then have a chance to revise in a way that is much more organic in the class than it could be. So we're scaling GPTA for 4 other courses at 3 universities this spring. One of the university might fall through, but we've definitely got it going on at University of Wisconsin this spring, where we'll provide rapid iterative feedback on student assignments in large courses. And we think we'll see more potential for learning gains there. Also going to be providing automated summaries for the teaching assistants and instructors so that they can know what happened in the discussion forums before the next class. How much work to take to build? This is the amazing part. It was so easy to build. 6 hours of my time. A junior faculty member part-time for 2 months while working on several other projects. 2 master students part-time over those same 2 months. And those of you who've built adaptive learning systems, question answering systems, yeah, right? It's amazing. You could never do this 2 years ago. We came up with the idea in like July. We had it running in August. One other example from our lab, runcodeapp.com. RunCodeApp is a introductory programming language environment used in Poland. And we developed better automated feedback for it using this prompt, where we told it to act as a Stacked Overflow post, explain Polish. The Polish worked. I don't read Polish, but my colleague Professor Pankowitz does. Told it don't write the solution explanation, focus on meaningful hints, include the line where the compile error occurred, tell it where the error was detected, and then give these details. It led to slightly better performance during learning. It led to initial worse performance after GPT hints were turned off. But after 6 exercises the students did with the GPT hints turned off, the experimental group was slightly more correct, and they were much faster, saving 93 minutes across the activity, despite doing slower at the beginning. So, in other words, this didn't just scaffold students, it provided something they learned from, which they carried forward after the class, after it was even turned off. And realistically, will it be turned off in the future? Most programmers these days don't program without a tool. They use GitHub Copilot or they use GPT or something. So realistically, it's not even a natural case to turn it off, but we did so just to see if they were actually learning rather than just being scaffolded, and they were. So a few reflections on working with large language models. And again, I don't know what will be news here to folks, but they're genuine reflections from our experience. First of all, if you give a different prompt, you get a different result, right? There's a lot of artistry still in writing these prompts. If you tell it to write a summary of how GPT works, you get something very different than if you tell it to do it for a 5th grader at a 5th grade reading level. Or if you tell it to do it for a PhD in machine learning who hasn't read a research paper since 2017. I use this sort of thing when I want to learn about areas I don't fully know, which there's a lot of areas these days I don't fully know. Or written for a highly intelligent person who knows essentially nothing about the topic. I use that when I want it to explain medical articles to me. Or sometimes you can give it a completion prompt. Ryan Baker's a professor of machine learning. He's explaining to a general audience how GPT works. He says, quote. Now, there's 2 different kinds of prompts here, completion prompts and request prompts. And they have different benefits. Completion prompts don't always work as well in GPT-4. You have to kind of cajole it now. They work in all the other large language models I'm aware of, including Mistral, Llama, Claude, and GPT 3.5. What completion prompts are really powerful for is if you want a more specific perspective. For example, Ryan Baker has some extensive writing in some areas, and if you ask it for Ryan Baker's completion, you'll get a different thing than just an average professor. I'm kind of at the very cutoff of where this works, because I have like hundreds of hours of videos of me on the web and an online course that's had a lot of subscribers. So as a result, Ryan Baker sometimes gives different things than the average. For some other colleagues, it doesn't work as well. Large language models are good at creating things that generally look right. They're not always right? Hallucinations. Putting together ideas in creative ways, like saying that I'm a monkey and my wife is a squirrel and asking for things from our cities. Factual information that's hard to search for. Adopting a voice or style where there's a lot of examples. It's really good if it's got a lot of examples in the web to work with. Incidentally, it works less well these days with 4 if you just let it search the web. You have to tell it not to search the web, and then it's often better. Getting in the right ballpark in the first try. Explaining reasoning, like for the qualitative coding. Amazing for that. Some people say, well, maybe it's not actually explaining what it's really doing. Who cares? The explanations are useful. Translation across languages, styles, etc. Summarize. Some current issues. Average reasoning. You ask it what a specific expert would say, they'll give you what a generic expert would say. And again, this works. This is more a problem the less renowned the expert is. And again, I'm kind of at that very cutoff where it sometimes works for me and sometimes doesn't. You get like a Nobel laureate, it always works. The more writing, interview, or talks are present on the web, the better it works. Not really getting at areas. Sometimes it just thinks you want something else. Being too helpful in guessing what you really want because what you asked for is uncommon, rare, or weird. AI interpreter is outright terrible, at least in the current version. Don't use AI interpreter or code interpreter or whatever they're calling it this week. It misinterprets its own graphs. It skips lines of data. It's absolutely atrociously bad. BARD isn't much better. Unreliability. Big problem for using these things for scientific purposes, right? The same post gets different results, even when you set the temperature to 0 and use the same random seed. They keep saying, oh, it's better now. We fixed that. And it keeps not being fixed. Yeah, I see you agreeing. Changes in versions happen quietly and change the results substantially. We hate this. Part of the reason we got that hostile post, we think, is because GPT changed version that week. And suddenly it was posting much more aggressively towards RTAs. It refuses to do innocuous things it used to do. Trying to be safe makes it too safe. For example, as of this writing, it won't write a scary story for a child anymore. My daughter loves scary stories and weird stories. I have to tell it to write the story for an English language learner who the reading level of a 5-year-old. Then it'll do it. It won't recommend tourist activities in Philadelphia's poorest neighborhoods. I guess it wants to keep me safe, but goodness, people go to those neighborhoods. That's almost kind of discriminatory that it won't give recommendations for neighborhoods that are a minority. Hallucination, making up facts or references. It's much better than it used to be, but it's still bad. It's surprisingly reliable for general facts, including facts that are hard to search up on the internet. I was driving a car in Italy and it said an add blue light came on, said add blue. And I was like, where do I get add blue? That's like a French additive. You go to the web, all the web pages are in French and they're not, where do you get add blue, right? Because everybody knows that. It's like, so I asked him and said, oh, go to a highway service station on this highway in Italy and you can get it. And it was right. How long should I boil chicken hearts for? That's a really silly thing to be hard to search on the web, but if you Google, you'll get all kinds of answers from 10 minutes to 3 hours. GPT gave a correct answer. But it can still get things wrong sometimes for obscure questions. I was recently in Paramaribo, Suriname, and I asked GPT, does it have a public library? And it turns out that Paramaribo does not. But it told me that this one place was a public library, and it wasn't. Because how could a city the size of Pittsburgh not have a public library, right? Average reasoning, it must. 3 months ago, ChatGPT refused to say that any city of any size, anywhere in the world, does not have a public library after lots of cajoling and prompting. Apparently, war zones all have public libraries. Refugee camps have public libraries. It just claimed that those cities didn't have web pages for the public libraries because, again, average reasoning, every city must have a public library. As of 1 month ago, it gave a vague, unclear answer instead. Incidentally, this is a test that fails most of the large language models. If you ask Mistral what the largest city in the world without a public library is, it actually gives the correct answer. And then if you say the second biggest one, it names a country. People also sometimes worry that these are just what they call a stochastic parrot. That's Emily Bender's term. Because these tools just create the most probable next word. So some people say there's no understanding whatsoever. And that's an open debate, but I don't think it's actually quite right. There's some model, even if it's obscure, underlying how the most likely next word is produced. And successful prompt engineering depends in part on being able to think like that model and understand what it'll do. And to think of how to make the answer you want become the most probable answer. So for example, like I mentioned earlier, phrase and prompt. you often get a better response if you tell ChatGPT it's an expert. And the more expert, the better, using words like famous, award-winning, or specific institutions like SNU. Doing so makes the answers associated with experts and the characteristics associated with those answers the most likely. In general, ChatGPT and other large language models are very good at perspective taking. And that's also the basis for a lot of ways that people hack or jailbreak them to get them to provide content they weren't designed for. It's a lot harder than it used to be with ChatGPT, still easy with Llama. But essentially, I'm jailbreaking it when I tell it that my story for my daughter is actually a story for an English language learner who has the vocabulary and grammar of a 4-year-old. So GPT may be a magic box, but it's not actually a magic box. It shines at tasks that were previously intractable, like auto-generating content fast, explaining its reasoning, and engaging in dialogues, aka our GPTA automated teaching assistant, our use of it in qualitative coding, our use of it in example generation for classification. But it's not actually revolutionary better for a lot of NLP tasks where decades of work have produced reasonable solutions, like short answer recognition. It's actually a little worse. Ultimately, what we're trying to do in the Penn Center for Learning Analytics is figure out where it'll be particularly useful. We've found so far that it's amazing for everyday tasks. It makes learning supports possible that weren't possible before, like Run Code App and GPTA. It's no replacement for current methods of text classification, but it can do things those methods can't. So thank you all for your time and attention. I'll conclude with just a few words. If you're interested in following our latest publications, you can follow them on these 2 feeds. It's low traffic. We don't spam you. We have a massive online open course, Big Data and Education, that teaches methods both for large language models and for other types of AI in education. It's completely free still. We have an online master's in learning analytics for any bright undergrads here. Our journal, Computer-Based Learning in Context, and Journal of Educational Data Mining. And all of our publications are available. Google Ryan Baker. I'm not the footballer, nor am I the real estate agent in London. Thank you very much. And I have no beard when you find me on the web. So apologies. 3 weeks. It's amazing what 3 weeks will do. Thank you all very much.
Thank you so much, Ryan. Well, you have quite different view on qualitative coding system from mine, so I would like to talk about it probably over lunch.
Please.
But
Yeah,
I hate them, but anyway, thank you so much for the talk. Yeah, so I
look forward to
think
debating.
I think we will probably have a few questions from audience in the room first, and then we're going to move to our Zoom. Do we have any questions? Okay, not yet. So, is there anyone? You can ask question in Korean. I'll try to translate if you feel like Korean is whichever language you feel comfortable with. You can 한국말이 더 편하시면 한국말로 질문하시면 제가 영어로 번역해가지고 라이언 교수님께 전달하도록 하겠습니다. 네, 여기 세 번째 주제. Yeah. Sorry.
Hello, my name is Jung Young-gu. I'm a PhD student at the Department of English Language and Literature in SNU. And thank you for your lecture. And actually, I'm writing my thesis about with using ChatGPT, especially in scoring. So I just saw your sentences in there, like complete prompt. Sometimes it didn't work in scoring. So actually, I wondered how you used how you use the ChatGPT in scoring, especially as when you ask the TA to score.
Are you talking about short answer scoring, essay scoring, program scoring, or something else?
Actually, essay scoring. So
Essay.
now I'm actually doing work like in using ChatGPT in scoring, like connecting ChatGPT in with my scoring work. So
Absolutely. Well, so this semester we haven't published anything on essay scoring yet. In general, the previous generation tools for automatic scoring are actually amazing, but they require lots and lots of examples. We've been able to fine-tune GPT using our grading from past semesters for student essays. And what it produces, I don't know that I would trust it to give the grade yet. But what we do is use it to give feedback. And it gives a relatively nearby set of feedback to what we currently give. if I was trying to actually give a grade, I would probably use the previous generation methods still. I think they're still a little bit better, but they require a lot more data and a lot more training examples than what we have. So it can be a useful tool. But for scoring, I would still have a human being probably check it. The way that, traditionally, a lot of automated essay scoring remains still one human score, one computerized score. Thank you.
저쪽 앞에, 네.
Thank you for all your interesting work with LLM systems. I was wondering, you commented on you're waiting for the day when Llama and other more available tools would be as good as ChatGPT. So are there some interesting observations that you observed between those more publicly available or free LLMs and ChatGPT?
Yeah, at the moment, what I would say is I actually Mistral. Mistral's current instruct is really good. It's really getting there. At the moment, I think that they're still more prone to getting confused, forgetting what they're doing in the middle. I would give the analogy of ChatGPT 3.5 versus 4. If I try to have a dialogue in basic Korean for my learning in 4, it handles it perfectly. It can take on the persona. If I try to do it in 3.5, it sometimes forgets which part it's playing. It sometimes makes some dumb errors. I think that Llama and Mistral are still in that level of making more silly errors. They're more on a level of 3.5 than they are 4. But the big advantage to 3.5 to those tools is that you can download a version and use it as is, whereas GPT is constantly messing with things under the hood. And it's really problematic to have something break in the middle of being used. And GPT's modifications break stuff all the time. So that greater stability as the competing tools get better, hopefully will make it possible to do a lot of what we're doing in a way that we can feel like it's more reliable. It just is nice to be able to control things and to get stable outputs back. So.
Thank you. 다른 question 있으실까요? 줌에 I think we have 10 more minutes left. Go ahead. Thank you.
저는 한국어로 질문을.
네네.
네. 저는 현재 중학교에서 애들 수학 가르치고 있는 교사인데요. 학교에서는 이런 오토메이티드 피드백 이런 것들을 좀 어떻게 앞으로 근미래에 적용을 하게 될지, 그리고 교사들은 어떤 식으로 이에 좀 적응을 해야 될지 그런 것에 대한 의견을 좀 여쭙고 싶습니다.
감사합니다. All right, here it is. So he's a math teacher at middle school in Korea. So he's wondering, because your talk has been based on the graduate or higher education setting. So he's wondering if you have anything to add about the situation in public school system, and especially about automated feedback system, how it can be used in school setting, and how teacher can be better prepared or feel about it. So having that automated system can cause a lot of different emotions. So you want to have anything to say?
Absolutely. I mean, I still think that it makes some errors when it's doing grading, but there's been a lot of really good use in K-12 of large language models for mathematics in particular. Conmigo is a particularly great example. And Conmigo, thanks to extensive training, really, from what I've heard from Kristen DeSerbo and others, doesn't hallucinate anything. It really gets the math right, it seems like, for the domains that they've built it in. And that's because they've spent, whereas our work was literally dozens of hours, they had a team of 30 developers working on it for several months. So Conmigo is an example in English at the moment, I believe, primarily, that really works for providing automated feedback in mathematics and engaging in dialogues. There's other examples as well. But yeah, I think the potential is really there for that. I don't know how it'll work in Hangukao still, but in English at least, it's been very successful.
So how teacher can be better prepared for it? Second part of the question.
Yeah, so I'm not sure if it's prepared for students to be using it or if, on their own or for students to be using it in class, but to the extent it's students using it with permission and they're using it to learn, I think the thing that teachers can be particularly prepared for is to send students who to these kind of tools who have relatively straightforward problems and can benefit from relatively straightforward practice, but keep an eye out for students who are still struggling. intelligent tutoring systems in general have had that character where generally the students who only need a little help benefit a lot. The students who are completely lost still often need a human being to work. So it kind of changes the role of the teacher to working with the students who need the most help rather than focusing on the students who are generally getting it. Thank you.
Thank you. So we have a couple questions from Zoom. Shall I throw them? Tiny little font. I think I got to age that I can't really read. So, so the person who asked question, she's a high school teacher teaching English as a foreign language. And she wants to ask a following question. The first one is ChatGPT can correct summaries and translate content with superb quality. Frankly speaking, I found the ChatGPT's correction far more helpful than mine. Could ChatGPT reduce the need for English education and English teacher? Wow, good question.
Could it reduce the need? I mean, I guess I would say that I don't think it's still a teacher. I think it's a corrector. I think it's a giver of feedback. I don't think that's the same thing. I think that grading is time consuming and annoying, and that people, especially if they're grading not in their native language, often still might make some mistakes. I think it can be really powerful for that, but I wouldn't say it replaces the teacher entirely. As a language learner myself, I find that I use GPT to engage in simple dialogues, but it's still no substitute for really having a conversation with an expert teacher. So I find it's way better than traditional homework. I would look at it as replacing homework, replacing grading, not replacing the teacher, at least not yet. And if you look at the various things online where people get GPT to simulate being a teacher, it's very repetitive. It struggles to figure out where the student is and maintain that over time. Maybe GPT-6 will be at that point, but GPT-4 certainly isn't. In my opinion.
Okay, so one more question from the same person.
Sure.
So it seems like she's using ChatGPT a lot, and she often meets a dead end with hallucination that you kind of introduced during the talk.
Sorry, with the what?
Hallucination.
Hallucination.
Yeah. So could you give us some pointers or thought experiments with ChatGPT with that kind of situation that she met the dead end?
Yeah. If it hallucinates, I mean, that's the thing. You've still got to be able to sanity check. I think in a lot of ways, the act of writing has shifted, and we may not all realize it entirely, because GPT can help us refine things. It can help us work from something simple to something higher quality. But what it can't do is catch that it's made a dumb mistake. And we still have to be able to recognize that. So if you're programming, you have to be able to recognize that it gave you something wrong. Maybe it can create it, but you still have to recognize it was wrong. And for factual information, you have to be able to recognize that this is probably not in the right ballpark. So it calls on us more. But how different was that than searching the web? If you search the web and you go to a web page, the web page could be wrong. And if you search the web and go to Wikipedia, Wikipedia might have been maliciously edited by somebody and no one saw it. Everything can be wrong. We still have to be good consumers of information, whether it comes from GPT or somewhere else.
Thank you. Okay, our
Thank you.
questions are flourishing here. So I'm going to move to Johan Cho's question. So thank you for the nice talk. It seems like you have mostly used ChatGPT in a zero-sum manners. I'm not really sure what that really means, but it seems like the question goes on. Have you observed cases where ChatGPT inherently falls short? It really need expert knowledge like yourself. So someone like us, probably lay person, how are we going to turn this into something very useful for ourselves? I think that seems like the question it's intending to.
Yeah, so first of all, ask it what an expert would say, not just ask it the question straight out. You'll surprisingly get a better answer a lot of the time. But I mean, clearly, for areas where there's scientific dispute, for areas where things are moving very fast, it might be out of date or wrong. And one of the areas, for example, that it gets often wrong in education is that in educational data, there's often a need to make sure that models work for new students. And GPT doesn't get that unless you tell it the name of an actual education researcher who works in the area. and then it can get it right. So there certainly still is a place for expert knowledge. Certainly ChatGPT does not replicate everything that I know in my area, nor does it replicate everything that other experts know in their area, because ultimately it's an average of the web. And even if you give it an expert, it may not know what the expert knows today. So there's obviously still a place for expertise. And ultimately, when ChatGPT knows something, it's because enough experts put that on the web in various fashions and crawled it. So it's never going to be quite the same as the most advanced human knowledge. But still, it's a lot better than, I can't think of any one person I know who could provide useful things on nearly so many topics.
Okay, thank you. So we have a couple more questions here, but I just want to make sure that the room is okay. So we're going to get one from the room and probably take another from the Zoom. I think that's how much time we have.
And if
before
folks
moving
have
on.
more questions offline, feel free to Google me and send me an email. I'm happy to answer it.
Or we can just ask ChatGPT. Do we need you?
It depends on the question.
All right.
Hello, thank you for your interesting lecture. I'm a undergraduate student of SNU, majoring in social studies education. Yeah, and I was wondering, like Google Translator can be served as language translator based on AI technology. In addition, ChatGPT can change the tone of speech, like casual to formal, etc. Like depending on the context at the same time at the translator. And I was wondering, do you use the two translator differently at different times, or do you mainly use ChatGPT? And do you think the apps that provide simple translator like Google Translator will be sustainable in the future, like 20 years later?
Well, so Google Translate's a lot worse than GPT. And Bard in general is really far behind its competitors. It's shocking how badly Google's doing. Google Translate's still useful. It's very fast and it works offline. So sometimes when I don't have an internet connection, I can pre-download the dictionary and it'll get me in the right ballpark. Google Translate's perfectly sufficient for everyday stuff like go to this building, but it's not sufficient for nuance or complexity or for rare languages. GPT is much more accurate in English, Korean from what I've seen. It's much more accurate in Portuguese, which is the language I speak fluently. In fact, my daughter, when she has slang questions in Portuguese, can ask questions that I sure don't know about what the slang is today in Rio de Janeiro, and I have. It also can handle minority languages much better. So I think GPT is slower, but a much better tool for translation. But Google Translate still has its place, particularly in offline translation. Thank you.
Thank you. So there are two more here. I'm going to take the last one first because it's really interesting. Many of my students are asking the same questions. So as you introduced here, that ChatGPT can make a lot of mistakes when it comes to referencing systems. The data is
Sure.
made of authors and papers. So the simple question asked by Park Yong-ha, he was wondering if you simply recommend us not use that for the purpose of collecting references.
Actually, 4.0 with web search is better for that than 3.5 was. 3.5 was utterly terrible at it. 4.0 is at a level where I still would go and check it myself. I'd still like just go over to Google Scholar, make sure that paper really exists. But for finding references, it can be a little faster than just using Google Scholar if you don't know what the search term is. So I wouldn't completely dismiss it. And incidentally, there's something kind of cool about 3.5 for references. I've gone in there and asked about papers I've written, and it's given me papers I haven't written, but I wish I would. And I've added some of those to my list of papers to write. So consider if you're looking for paper ideas, ask it what 3.5, what some professor that you think does cool work has written, and then go and see if they haven't written that paper, maybe you can.
Oh, good. Yeah, good recommendation. Very last question here. So Joe was asking, so I was wondering about this as well. Stochastic parrot. I don't really know. And he was wondering what set it apart from being one of them.
So the idea of stochastic parrot, the idea is a parrot just repeats things without understanding. And stochastic means kind of statistically most probable. And so Emily Bender and others have said that ChatGPT is simply, that's what it's doing. And I think the thing is that might even be true, but what it implies is that there's no model, there's no meaning. It's just putting out garbage. And most of the time, ChatGPT is not putting out garbage. There's a complex model under there, and that complex model behaves in a way that that mimics reasoning. And that's why it can be useful. If it just generated the most like GPT-2, if you played with that ever back in the day, it really just generated garbage that was hilarious a lot of the time. 3.5 and 4 don't generate hilarious garbage most of the time. They generally generate stuff that's useful. It's an alien intelligence that functions nothing like us, but still can produce intelligent behavior. Honestly, how do we know that any of us are intelligent? How do you know that anybody else is truly intelligent and not just a simulacrum? It behaves in a way that acts intelligent like human beings can. So that's an interesting place to end. I look forward to the next talk. Thank you.
Thank you so much. Let's give him a round of applause. So we're going to move to our second speaker. 두 번째 연사를 모시도록 하겠습니다. 그래서 다음 강연자는 영국 유니버시티 컬리지 런던에서 오신 무틀루 쿠쿠로바 교수님이십니다. 교수님께서는 UCL의 학습 및 인공지능 교수로 재직하고 계시면서 유명한 해외 저널 British Journal of Education Technology의 편집장을 맡고 계십니다. 그래서 AI 시스템과 함께하는 미래 사회에서 마주하게 될 교육적 도전을 효과적으로 해결하기 위한 방안을 굉장히 활발하게 연구하고 계시고요. 또 유튜브 비디오 찾아보신 분들 아시겠지만 이분이 굉장히 비판적인, 또 AI에 대한 굉장히 비판적인 관점을 갖고 계십니다. 그래서 이번 심포지엄에서도 그런 관점들이 빛을 보게 될 거라고 기대되는데요. 그래서 이번 심포지엄에서는 현 인공지능 개발과 활용 패러다임이 가진 한계를 말씀해 주시고 또 그 한계를 극복하기 위해서 정말 휴머니스틱한 인간 중심적 접근을 교육에 어떻게 적용할 수 있을지에 대해서 따뜻한 강연을 해주실 예정입니다. 그럼 큰 박수로 우리 무틀루 교수님을 모시도록 하겠습니다.
Right. Hi, everyone. Thank you very much for this kind invitation. It's an absolute pleasure and honor to be here. My lecture is a lot much broader than Ryan's talk. It was specifically focusing on large language model, which I did enjoy quite a lot. I was given the insight that most of the audience today will be graduate education researchers, which I think some people might or might not have any experience or background in machine learning or artificial intelligence particularly. So I want to take a much broader take on today's lecture. I will be broadly talking about quite a few topics, trying to kind of mention AI implications for education, and we'll try to give some of the examples from my own lab and from my own team's research. Obviously, I will not be getting into the details of any of the specific studies, but I would be very happy to discuss further if you have any questions about any specific research project that I will be mentioning. I try to add some of the references, but probably they are not all there. So let me start by, oh, you know what, I don't even need a clicker. It's okay, thank you. So let me start by giving a very broad definition of AI. And I usually do this because I've been giving talks over a decade about AI, and most often people have been coming to my talks with either no idea about AI or very unrealistic expectations about AI, because I'm part of the Faculty of Education, and many of the researchers that I have been engaging with, more specifically, more traditionally looking at educational settings. So I always assume that it's always good to start with a definition. And I give this broad definition about AI referring to simulation of intelligence, which I think is extremely important to refer to the simulation word here, which indicates the imitation of intelligence, not really the real construct per se, which goes back to this stochastic parrot discussion from the Bender's work as well. In AI, intelligence is a surrogate of the actual real construct. It is being somehow modeled as an approximation of the real construct itself. But when it comes to applied AI, which is the case in AI in education, most of the time it kind of goes down to these tools that are designed and developed to assist in or replace decision-making processes through analysis of big data and prediction of the best value for a designated outcome variable, which is then conveyed through a user interface. As many people now are familiar with artificial intelligence through tools like ChatGPT, maybe it would be a good example to briefly talk about it based on the definition that has been provided. It is essentially trying to replace or support decision-making processes through the analysis of web crawl data. Here is the data that GPT-3 is based on, which you can see mainly web crawl data in English, which has significant implications on the use of the tool in different languages. Then there is a fine-tuning through a process called reinforcement learning with human feedback, which is a subfield in machine learning that essentially looks at when it is very difficult to specify a reward function for a reinforcement learning process, you look at feedback from humans to be able to represent the desired behavior that you are trying to achieve. And in essence, it is trying to predict the best value for a designated outcome variable, which in this case is the next word sensible. And it is conveyed through a user interface, which is extremely user-friendly, in my opinion, compared to many of the previous AI tools. Do I speak too fast? Is it okay? The speed? Okay. So what are the implications of AI for education? I think, broadly speaking, in my opinion, there are three categories of implications. One is the design and use of AI technologies to support teaching and learning. I think most of the work that I have been doing and the Ryan's research that he has presented looks at this first aspect on the design and use of AI technologies to support teaching and learning. But in addition to this, there are two categories of research that is related with AI implications for education. The second category is about educating people about AI so that they can use these technologies effectively, ethically in their lives. And the third category of research that looks at innovation in education systems to be able to prepare our students for an AI-driven world. So there are significant innovations that are required in education systems that are implied because of the ubiquitous use of AI technologies. And I think all three are very interesting research areas, but because of my own research interest, I will be mainly focusing on the first category, on the design and use of AI technologies for teaching and learning. So if we look at the designing AI for education, I think there are three conceptualizations of AI. AI can be designed to externalize, to be internalized by humans, or extend human cognition. As the first conceptualization in the externalization of cognition, certain human tasks are clearly defined, mathematically modeled, and then replaced by AI. In the second conceptualization, AI models can be used by humans to be internalized to change their representation of thought. So these are more transparent, good old-fashioned analytics-based approaches. And they are used to be able to change the representation of thought in human being, in human cognition. And then there are these techniques that are particularly focusing on what we would like to call as hybrid intelligence, that are tightly coupled human AI systems. Now, I think it's really important to focus on this extended cognition conceptualization to note that in such systems, the whole is expected to be more than the sum of each agent's intelligence. So human and artificial combination is expected to lead to a larger intelligence to be able to achieve things that neither of the agents or the sum of the intelligences would be able to achieve. And this is expected to happen through dynamic interactions between the two that leads to human capability augmentation, as well as human contributions into AI to be able to improve its performance and capabilities. Now, I think Ryan has given some of these examples, but historically, the most common applications of AI in education have been the adaptive learning systems, or some people would like to call it intelligent tutoring systems. But I really liked a paper that Ryan written a few years back that refers to the stupid tutoring systems and intelligent people. So I'm not really sure if we would call them as intelligent. I would call them as intelligent tutoring systems, but sometimes they are referred to as intelligent tutoring systems. And these are systems that can adapt to the individual needs and abilities of each learner, tailoring to the educational content, feedback, and pacing accordingly. In essence, these tools are trying to achieve support that would help each individual student to achieve their full potential. Some examples are provided here, earlier examples from Carnegie Mellon University, the Carnegie Learning, some language learning examples like Duolingo. I'm sure some of you would be familiar. And Ryan also talked in detail about Canmigo, which is the one of the most recent versions with the use of large language models as well. But in addition to these kind of systems where the adaptation can be directly provided to the student-facing platform, there could be insights generated and provided back to the teachers as a teacher-facing dashboard. So the assumption here is that these kind of AI-driven, analytics-driven insights can help teachers adjust their interventions according to the data-driven insights provided to them. To me, I think it's quite interesting to note that most of the work in this space of AI in education historically, which I think is such an innovative research area, has almost always been a quite innovative research area, considered as an innovative research area, mainly focusing on a traditional pedagogy of somehow one-to-one instruction or direct instruction. And there might be various reasons why such direct instruction pedagogies have been the main focus of AI in education. They are often characterized by structure. They are often teacher-led pedagogies. They require explicit teaching of particular concepts. It is a long history with strong research evidence of effectiveness if you measure knowledge acquisition and factual recall as the main criteria of the learning outcomes. Many educators and curriculum developers are well familiar with these kind of pedagogical approaches. And as a researcher in this area, AI applications do indeed thrive in these kind of structured environments and structured pedagogical approaches. Now, it's a very fair question to ask what has changed with the introduction of large language models. And I think Ryan has given some really good examples, so I'm not going to really get into the details here. But to me, perhaps one of the really interesting changes is to be able to decrease the amount of time and expertise that would be required to be able to build these systems. Traditionally, intelligent tutoring systems have been requiring very significant amount of time and expertise to be built. But these days, large language models can help very significantly to decrease the amount of time and effort that are required to be able to build this. I think one of the really important aspects is the no coding or low coding expertise that are required to be able to fine tune and adjust and build these large language models, which essentially means that real heroes, in my opinion, real stakeholders of educational research, those teachers who are practitioners, can indeed now be first-hand developers of some of these technologies, which I think is a significant advantage. Maybe it was not really mentioned in previous talk, but to me, one of the real advantages also relates to this idea of potentially being able to generalize large language models. Intelligent tutoring system models, traditional machine learning approaches, tended to have very low generalizability between different tasks, between different contexts, whereas large language models have a significant advantage in terms of being able to generalize to issues. But this is not to say that large language models do not have their disadvantages. I think, again, these were somehow mentioned in previous talks, so I'm not really getting into the details here, but maybe it is extremely important to refer to this idea with regards to the reliability, which I think is extremely important. To me, these reliability issues that relates to the model's lack of real world understanding might be a significant problem. Although there are some progress that have been made, we find it extremely difficult to be able to actually justify the rationale provided by large language models. So the no reliability of the chain of thought explanations from the model in our work of space has been shown. There are significant issues with the fact that we as academics are struggling to build a model of our own at that scale because we don't necessarily have the resources, which essentially means that we rely upon these commercial models, which are extremely challenging because, as Ryan mentioned, these models can be updated very frequently, very quickly, which has significant implications in their research and educational practice implementations. There are also significant concerns about the obscure data storage and copyrights. And there are quite a few lawsuits about the use of data in these large language models, which obviously have significant implications for to what extent they can be used in educational research and practice. So to me, these large language models are not necessarily the panacea for all the challenges of the field in AI in education, but they can be certainly a strong and important tool within the toolbox of an educational researcher and practitioner. So depending on the case, the goals, the expertise of the designers and the researchers, you might prefer one particular modeling approach over the other. I am quite skeptical of some of the colleagues who are very strongly arguing about the future of AI essentially being on large language models. I think we need a lot more diversity and versatile considerations in this space rather than focusing on only one particular approach. As you can see, this is an AI-generated image, for instance, which has a lot of gibberish in it, and this is GPT-4, but it gets very bad in terms of image generation of letters. So what has been the impact of these kind of AI in education approaches with regards to adaptive learning platforms? Obviously, we would always benefit from larger scale evaluations and more number of RCTs. But I think the good news is that there has been both at an individual study level, but also at the meta-reviews level, significant evidence showing that these systems can achieve comparable results to average human tutors in the delivery of knowledge acquisition, in particular subjects like math, algebra or language acquisition. So this begs the question, for the last 3-4 decades, we have been generating evidence about the value of these approaches at various levels. Why these technologies are not so mainstream still in educational ecosystem? Why don't we just plug our individual students to work with an intelligent tutoring system and get on with our lives? This has not been the case, and I think there are various reasons behind this. I think if education is considered in this narrow sense, in a vision for the future of education as lonely individuals working on their own with an intelligent tutoring system, then AI can indeed dehumanize learning experience, encouraging students to focus on the completion of particular tasks rather than supporting learning by engaging in rich social experiences. Such an approach might lead to learners prioritizing information gathering and declarative knowledge acquisition over tacit knowledge and over wisdom, which comes through these social learning experiences. If these systems are considered as a replacement for human interactions with each other, and with the real world, then the knowledge that comes through these experiences and practical acquisition of an embodied skill can be replaced with tokens of representation of what we think or what these tools can model as these experiences, which I think is quite diminishing in many senses. So thinking about, I mean, I was actually given the task of thinking about what could be the future then of AI implementation in educational settings. And I think many of the genuine learning outcomes we are interested in education have not really been the traditional focus of AI in education research and practice. You know, those learning outcomes that are associated with critical thinking, collaborative problem solving, those associated with ability to regulate one's own learning within the context of social setups, social shared regulation of learning, adaptability and flexibility skills, creativity and innovation skills, reflective thinking skills. And I think these learning outcomes emphasize active and experiential learning where students construct their own understanding and knowledge of the world through rich experiences rather than only monotonously engaging with an intelligent tutoring system. But designing AI for such constructivist learning approaches is significantly more complex due to the unpredictability and variability and lack of structure in these kind of learning approaches. In my own team, we have been for a decade or so focusing more on these kind of aspects that relate to modeling and supporting social, emotional, and metacognitive aspects of learning. And I think the future of analytics research and AI in education research is more likely to focus on these kind of approaches, in addition to more traditional pedagogical approaches that I have mentioned. So this is an example of a learning environment that we have been studying for quite a few years, in which students are working as a group together on an open-ended task, designing solutions to particular problems. And then the system has been collecting data, multimodal data, looking at students' two-dimensional and three-dimensional videos, looking at students' facial features, and looking at students' gesture analysis. Students were asked to wear fiducial marks for us to be able to track their hand movements and speed a lot more accurately. We ask students to write their reflections on a mobile tool, and then we track all the content inputted in this mobile tool. We look at the amount of time that they spend in different phases of their design thinking, as well as looking at self-declared emotional states. So if we take this more kind of traditional AI approach of trying to build a prediction model of students' competence based on these kind of data, you know, you look at certain multimodal data, you calculate certain independent variables based on these. Here, a set of examples can be seen here. You look at the amount of time that they spend in different phases of the learning activity, and then you use these as an input. You use expert labels as the output. So you ask education researchers, learning sciences researchers to be able to label accurately the students' competence on various educational constructs. And then you are trying to build a machine learning model that would accurately predict these scores that the experts are giving to each group, or looking at certain classification tasks. So, for instance, we have been looking at classes of high competence, medium competence, and low competence groups. Now, here you can see some of the F1 values of some of the models that we have built using more traditional machine learning approaches. And you can see also neural network results of the regression task. These are the top ones are F1 values, and the lower ones are the root mean square error values. To me, one of the really interesting findings of this kind of work is that added multiple modalities oftentimes increases the accuracy of prediction. So that's a really interesting finding, because oftentimes people have been looking at unimodal data, you know, only logs of interactions, or only audio data, or only video data. But we tend to find, particularly in these kind of more complex learning activities, added modalities can increase the prediction accuracy. And we have been also looking at what modalities can achieve the highest prediction values. to me, these are really interesting research problems, but they are toy problems, really. I don't really think that these kind of systems have much value in real world practice. We did actually work with teachers to be able to see, to what extent these predictions have value for teachers. And it was very interesting. If you showed accurate predictions of competence, or let's say collaboration competence or collaborative problem solving competence to the teachers, one of the first questions that they ask is why? And another question that they ask is that how do I help those low competence students to move to high competence? And with this kind of machine learning approaches, it's extremely difficult to be able to provide insights as feedback to the teachers and to the students. So instead of this, we have been looking at trying to dissect these huge construct of collaboration or collaborative problem solving into sub-constructs and trying to model each one of these sub-constructs with different modalities of data that could help a teacher use these insights as a feedback opportunity, or a student to use this as an opportunity to reflect upon their own practice. So here you can see an example of a computer vision model that we built. It essentially tracks each individual student and object within the group and predicts where they are looking at. So looks at the gaze behaviors. In addition to this, we have been looking at non-verbal speech behaviors in terms of whether they are speaking or not. And then we were combining these non-verbal gaze behaviors and non-verbal speech behaviors as part of a transparent algorithm that predicts 7 educationally meaningful behaviors. For instance, if a student was speaking and the other students were looking at the student who is speaking, that was labeled as a moment of interacting with peers. So then these kind of transparent predictions can be used as feedback opportunities for teachers based on the certain behaviors. And this is the nonverbal behavior aspects, but we have been also looking at the verbal aspects and indeed comparing the potential of different modeling techniques in terms of detecting students' challenge moments, more traditional NLP approaches versus generative AI approaches, for instance. I think our results are very aligned with what Ryan presented in terms of the performance. Still, some of these expert models can achieve better predictions, but they take a huge amount of time and effort through feature engineering to be able to build these, and a lot of data to be able to model these. But similar results can be achieved with large language models. We have been particularly looking at GPT-4 in terms of detecting challenge moments. I have to say, to me, qualitative analysis through generative AI models, large language models, highly dependent upon the particular coding schema that we are using. For instance, in our challenge prediction models, we were achieving very high results. But when we try to do predictions on the type of challenge in the student's discourse, the prediction values decreased significantly for particular challenges. For instance, the GPT-4 really struggling to be able to detect those metacognitive challenges that students were having, whereas it was very good in terms of detecting challenge moments that relate to factual information or misconceptions or task-related issues. So to me, it is highly dependent upon what we are trying to label in this qualitative data, and that would be leading to different results. I guess this is more or less the same for human labeling as well. I often find interrogative reliability of metacognitive labeling quite difficult among humans as well. So let me show you a few examples of how we use this feedback. So both of these multiple modalities of data are essentially sent back to the students through an app that we have built. So these are showing essentially the amount of time each individual student was speaking in terms of proportion of time across different weeks. And as you can see, for the first couple of weeks, particular students were dominating the discussion, but with the feedback provided, there are increased equality. I'm just trying to understand who is taking my slides here that we can see. So as you can see, throughout the weeks, the equality of contributions changed in students. In addition to this, you can see the specific type of actions students were engaging in. Here you can see that this group in week 2 was spending most of their time in mutual discussions and spending the majority, a significant amount of time on one student explaining to the rest of the groups, and spending very little amount of time on research management, which were the moments where individual students working on their own laptop and not really engaging with the collaborative activities. And so in addition to this, you can see here the 7 type of collaborative acts that our algorithm predicts and the amount of time the group spends in this particular week. And we have a rule-based feedback template. So essentially based on the certain amount of time spent on different actions of collaborative learning, the system generates a feedback to the students, providing advice on how they could improve next week. In addition to this, we have been looking at similar visualizations based on the discourse analysis of their discussions. Here you can see in one group's 1 week activity, what kind of challenges that they were having and what kind of regulatory behaviors they were engaged in to be able to solve these problems. And we have here 2 different approaches. We have one rule-based feedback template, again, based on the certain threshold values. If certain threshold values are above or below, then the feedback would be adjusted accordingly in terms of how they could improve their practice. But we are also exploring here to what extent a generative AI can be used as a feedback opportunity. And I have to say we were not that successful in terms of using fully automated feedback here. The reliability of the feedback, particularly for, as I mentioned, these emotional challenges and metacognitive challenges were not very accurate. We have been obviously monitoring all of the feedback that had been generated, and we were not very happy with the quality. So we didn't really send these back to the students. So I guess it's really important to think about in this kind of feedback generation, what kind of task on which we are providing feedback. Perhaps if the task is more factual information driven or factual information seeking, then the generative AI could work well. But if your feedback is on how they could regulate their behaviors at a metacognitive level, maybe the generative AI is not there yet. Now, there are significant concerns in some of the areas about this kind of more intense data collection approaches with regards to privacy concerns and ethics. We have been studying students and teachers' reaction to this kind of analytics and AI-driven feedback. And I have to say, I think it's really interesting for me to observe that although in the initial interviews, many people tend to say that they have significant privacy concerns, in our experience, these kind of concerns tend to fade within the 2-3 weeks of time. So students at the end of, let's say, 10-week intervention, oftentimes mention that they don't even realize anymore that these tools are there and they're being monitored. And many students found it extremely motivational because it provides accountability of their actions. So it's not really that negative in terms of the privacy concerns. One thing that was really interesting for us to observe students gaming the system behaviors, as Ryan likes to call these. I think so. If the system was only focusing on nonverbal interaction, so imagine the system looking at the amount of speech from individual students, it was so interesting that students quickly moved towards gaming the system. So let's say 1 week, one particular student was not speaking at all, and this was visualized back to as a feedback. And the next week, the students were allowing space to this individual student just to talk about football, about fashion, whatever they're interested in, to be able to increase their speech time, but not really focusing on the content of the task. Now, to me, that is a double-edged sword because it looks like it is gaming the system behavior, But actually, in terms of social bonding and in terms of ethos of group work, we have found that this kind of off-topic discussion can be very valuable, because students were bonding, and then they were a lot more motivated to be able to work together at the end. But I wanted to say that in terms of increasing awareness, students' self-awareness of their action, increasing their accountability of actions, these kind of AI-driven analytics feedback are extremely valuable. So I've been reflecting upon this question about, you know, what could be the future of learning analytics based on AI, and to me, but if we consider most of the traditional educational technology as kind of low human control, low automation technologies, I think most of the initial vision of the field has been focusing on very high automation, but low human agency approaches. And perhaps many of the existing analytics techniques and good old-fashioned kind of rule-based traditional AI approaches are focusing on changing the operations and representation of thoughts, those simple statistical models of analytics that are presented back to people, so that people change their understanding of what good looks like based on these models. And perhaps potentially we are a lot more likely to see in the future those approaches that are highly competent advanced AI tools are providing in tightly coupled human AI systems high agency to the learners. And I think one of the really interesting challenges within this area is how to be able to ensure human agency in terms of their interaction with the AI tools, while we are still taking advantage of advanced AI techniques. So maybe considering the limited amount of time that we are provided, I will stop here to move towards a particular direction that relates to the other two aspects of the AI implications for education. As I mentioned, there are two other implications. The second one was about improving people's understanding of AI so that they can use it effectively and ethically. So this is about educating people about AI. In this space, I think most of the work has been specifically focusing on how do we improve people's technical understanding of AI with a very limited scope of what AI competence is, whereas ignoring many of the other important dimensions that relates to human-centered thinking, that relates to ethics of AI. And I think we are a lot more likely to see those approaches that are related to the competencies that are associated with these multi-dimensional considerations. As part of my work within UNESCO, I have been chairing an international expert group that focuses on building AI competency frameworks for teachers and students and non-experts in this area. And I just wanted to highlight here, this is the most current version of the framework that we have been working on. And as you can see, it has 5 aspects and 3 progression levels with 15 competency blocks. To me, most of the people and most of the previous work has been focusing on how do we educate people about AI foundations and applications, so those AI techniques, application skills, but ignoring the other aspects of the multi-dimensional construct of AI competency. At last, maybe I can mention within a couple of minutes those implications that are associated with the required innovation in education. I think most of the people would be very familiar with the discussions when the first ChatGPT was introduced within our educational institutes. All of these concerns about students cheating, all of these concerns that are associated with the plagiarism and how do we cope with our assessment systems. In my own teaching, I have also a lot of assessments that are essay-driven, and I do find these concerns valid, but I feel like they are oftentimes missing the main point. To me, when we give an essay writing as a task, as an assessment task, most often the final outcome, the final product as the essay itself has very limited value for us. We are giving these tasks because we expect students to develop important competencies through the process of writing this essay. So to me, that requires a significant shift in terms of what we should be evaluating in the first place. Only looking at the outcomes of essay and assessing the final products has very limited value. But looking at the process of how do students engage with the essay writing is a required innovation in our education systems that is particularly important now that AI technologies are ubiquitous. So in my own at UCL teaching for the last 5 or 6 years, I have been looking at students' process analytics of essay writing. So instead of only giving feedback and final grades of the final product, we have a back-end tools that traces students' engagement with the essay writing tasks. So we have been looking at how much they space their practice, how often they write, what kind of edits do they do, whether they are cramming the night before 2 hours, 3 hours to submit an essay, or they are spreading their essay writing practice throughout weeks to be able to submit the final product. And it's really interesting when we looked at the impact of these kind of analytics feedback provided back to students, the most benefiting students were those who were initially either predicted to fail or those students who were predicted to have a low competence in terms of regulating of their behaviors. Some of the high competence students, those who were predicted to achieve very high grades in the first place, they didn't even look at the feedback most often times. But those students who were predicted to fail or were classified as low competence students were the ones who were benefiting the most from such an intervention. So this kind of innovation that is an innovation in education system that requires us to look at our assessment practices based on the fact that AI technologies are ubiquitous now is one example of an innovation that is required in education systems now that AI is ubiquitous. So maybe to conclude, I would say that AI analytics are likely to impact education significantly. It already has to a certain extent. There are implications on the design and use of AI technologies for teaching and learning, implications on educating people about AI, and implications on innovating education systems for an AI-driven world. I would say that different conceptualizations of AI solutions are likely to lead to different degrees of benefits and challenges. Don't get me wrong, all kind of AI conceptualizations of externalizing, aiming to be internalized, or extending human cognition can provide certain benefits. We have projects looking at fully automating, for instance, the video generation for teachers to be able to put their educational content to online setups. And this is a task that teachers appreciate significantly because it saves them a lot of time and doesn't really have negative repercussions in terms of human cognition and teachers' capabilities. But human AI collaborative systems to augment human capabilities can be more valuable for many of the learning and teaching environments. And I think it's really important not to forget that oftentimes when we think about AI in education, we tend to focus on very specific problems of how do we improve the prediction of accuracy of a particular model? How do we improve a particular algorithm? But oftentimes, these kind of technologies are part of a large-scale ecosystem, and the ecosystem implications of any of the changes that we are aiming to bring in our AI technologies should be considered part of this large ecosystem. So I'll stop here, and thank you. Oh, yeah, sure.
Thank you so much, Mutlu, for the very exciting talk. So we have a lot of questions. I think audience has been heated up, but I'll go for the audience in the room first. Okay, this one.
Thank you so much for a very interesting talk. My name is In-Suk Khan from the Korea University. I have actually two questions, one micro level and macro level questions. The first one is about the multi-model analytics that you presented about your study. You already said the challenges that you can face between mapping those behavior indicator to the construct you're interested in. I'm always wondering how you can actually name that behavioral indicator that you can observe from the multi-model data with the construct that you're interested in, how to actually make sure that that's the indicator that you're looking at for the construct that you want to measure. So if you can give us some of the examples that you found most challenging to name those, to map between those two. That was the first question. And the second question is more like a macro level. And I'm 100% agreement with what you said about the process-focused evaluation instead of the product. But still, in the educational system, in the current system, we're much focused on the evaluating the outcome of the students that they produced at the end of the learning activities. So I'm just wondering whether you observed very interesting things about the students. So because in the research they presented, you were focused on the collaborative competencies that you measure. So I'm just wondering if you found any interesting interaction between what students presented in terms of their collaborative competencies with the outcomes that actually produced at the end of the learning activity.
Thank you for brilliant questions. I think starting with the multimodal learning, is this on? Oh, okay, it is on. So my ears are blocked because of the slide, so I can't really hear myself speaking. That's why I'm asking. With regards to the first question about the multimodal learning, I think that's a really interesting question. To me, most of the learning sciences research and work is exactly what you're asking. How do we move from these clicks, these logs, to the constructs that we are interested in? And I think this is not really one way of moving from either raw data to the particular features and then from these features to the constructs, or moving from constructs to the data. We oftentimes look at both inductively and deductively. So deductively, we look at the existing learning sciences literature, look at the particular constructs that we are interested in, and see how existing educational researchers, learning scientists have been evaluating these constructs, and then try to identify modalities of data that might represent those constructs that existing researchers, learning scientists were looking at. So just to give you one example of a very difficult to process data, we have been looking at physiological data in some of our work, looking at the EDA and the skin conductivity to be able to look at the arousal levels of students. And in this, one of the core constructs that we have been focusing on small group work was the synchrony of their arousals. So we have been looking at the peaks of arousal levels based on the skin conductivity data, and to be able to see if the peaks of individual learners are synchronized in effective group work, because the literature in learning sciences indicates that higher synchrony might represent better learning outcomes in terms of effective collaboration. So this is looking at it from the learning sciences point of view, trying to identify the data and then decide about the core construct. But it can also well work from the other way around, which we are exploring indeed, that we have access to different sources of data and different modalities of data, and trying to find more innovative ways of correlating these inputs that are calculated with the different modalities of data that relates to particular learning outcomes. For instance, it might be shared understanding. So we collect shared understanding from a self-declared data and manual evaluation of students' products in the group work, and then trying to see if there are correlations in our collected data with these kind of outcome measures that we are interested in achieving. So that's to answer your first question. Going back to the second question, I do agree that there are significant challenges in terms of the existing school ecosystems and education ecosystems to move towards more process-oriented assessments and evaluation. But if there is, and these are not really new things, you know, in educational research, people have been talking about the value of process-oriented assessments and evaluations for long decades. But to me, the urgency of the change and the need for the change has been accelerated very significantly with the advancements of AI technologies and the ubiquitous use of these technologies. I have been doing AI ed research for over a decade, and we have been working on these models, but they were models that only we were working in our small groups, you know, in our small research teams. Now, these kind of large language models are all out there. Everyone is using them. Everyone is now engaged with AI. So the urgency to move towards these kind of changes has accelerated significantly. To me, that's one more argument to add to the discussions about the macro level changes that are needed. And I think we should take advantage of this.
Thank you. You know, I can't resist. I have to use chair's privilege to ask my question, which is really touch upon the first question of that. So I saw the photo that you have used. It looks like all students are Asian students that you are working with. So my question is that, especially when you try to detach the emotional challenge, you know, using those body language or whatsoever that you can observe, that I think different culture has different way of expressing the frustration and challenges. And I'm pretty sure the humble British people have their own way of expressing it, very different from Asian students. So I'm pretty sure that you have thought about it, but if you can touch upon a little bit of criticality there, that how you can maintain and how you can, you know, for sure that it's the predictions, the behavioral kind of, which can be predicted that students are going through some emotional challenge.
I mean, that's a really good question. So let me start by saying that in this particular computer vision system that we built, we don't necessarily look at the students' emotions based on the two-dimensional video data, but there are people who are looking at this. And your question is still valid in terms of the differences in different cultures on how to express their interaction in non-verbal manners. For instance, we have been collaborating with colleagues in Osaka University and doing cross-cultural comparison of these non-verbal interactions in small group work between the students in the UK and the students in Japan. And it's really interesting to observe the differences between the two. In the Japanese culture, students tended to avoid eye contact, which was one of the core constructs that we were modeling in this computer vision approach. Because if a student is speaking and the other students are looking at the student, that indicated an attention and accountability of the things that the student was speaking. Whereas in Japanese culture, students were still listening to the student who's talking, but they were not really looking at the student. So there are these kind of differences indeed. And the point that I would make here is that we are not really arguing about the cross-cultural constructs that are universally valid as accurate behaviors or the expected behaviors. This is a lot more about being able to generate those insights, model those constructs that are relevant to effective collaboration, and present these back to the students, present these back to the teachers as a self-reflection tool, as a feedback tool. Then the humans and human intelligence can decide whether this was a destructive behavior or it was actually indeed an appropriate behavior for this particular context within this particular culture. That's why I think fully automated interventions can be very problematic, and universal implementations can be very problematic. And in your question, there is also the dimension that relates to the ethics of these models in terms of being able to detect accurately students' emotions from different cultures and students' gestures and faces from different cultures based on different skin colors. And this ethics of AI dimension is also a very important dimension, but I am assuming that this is slightly tangential to your question, but I would be very happy to talk about it if there is interest in this space as well.
Thank you so much. So I'm going to go to the question from Zoom. Yeah. So Sojang asked questions that in order to develop AIs in education, do you think that it's necessary for, I think, educator to collaborate with engineers in computer sciences? If so, what roles do each field and expert should play?
Yeah, I mean, to answer the first question, yes, absolutely. I think for long years, different stakeholders of educational research and practice have been working in silos. You know, educators and education researchers working in their own conferences, in their own spaces, and doing things in their own space. Same with the computer scientists, building models, you know, thinking that this could well work in a real world classroom environment, but not really have been to any of the real world classrooms for the last 20, 30 years. To me, there is great value in this kind of cross-stakeholder collaboration, both in terms of research and in terms of practice. That's why I think there is great value in the kind of research institutes that SNU has just launched, the Learning Sciences Institute, where people who are coming from different backgrounds, who have expertise in different areas, can bring in their own expertise, understanding, but also their own lack of understanding and misconceptions. In my experience, many of the scientists, computer scientists that I work with, and my own bachelor's is in engineering, so I am one of these people as well, we have very limited understanding of how real-world classrooms actually work, and what are the real-world problems of teachers. So we do provide solutions oftentimes to problems that do not really exist in real world, or not that urgent. So I think there's strong value in this kind of cross stakeholder collaborations. That's why we do highlight and prioritize participatory design approaches, co-creation, and co-design approaches as part of our research and our design and development of the tools, not at the final evaluation stage of, oh, we built this tool, let's take it to the stakeholders and see what they think, but at the very first conceptualization level of, is this even the right idea for which we should be working towards creating a solution?
Thank you. I totally agree with you, by the way. I remember there was one hand up behind Professor Insu. So was it? Yeah. Oh, so I'm sorry, I snatched your question. I should have waited. Okay, so any other question from the audience? Oh, okay. If not, I'm going to move to Zoom question, maybe. So thank you for the insightful lecture. I have a question about the study. Was there a difference between the results analyzed by AI and the participation behavior perceived by students?
Yeah, I think that's a really good question. So let me put it this way. For the purposes of evaluating the performance of the models that we are building, we do actually manually watch, I mean, researchers in my team and graduate students are actually watching these videos to be able to see the performance is matching in terms of accuracy of detecting those behaviors. So, and we have multiple papers that I think I put on my slides, but if not, people can approach me and I can share. So this kind of computer vision's accuracy in real time, real world settings is reaching about 80%, 80 to 85%. So that's one thing in terms of whether it is able to detect these kind of nuanced behaviors accurately. Another part of the question is I guess, asking whether students think that their behaviors are accurately detected. And there we find significant differences. Oftentimes, those students who, let's say, tend to speak way too much in a group work, when they are asked at the end of a group work how much they were speaking, they struggle to judge their behaviors accurately. They think that they were allowing enough space. They think that they were providing opportunities to other students. So one's ability to judge accurately their own behaviors in this kind of complex social learning environments, in our experience, is quite limited. And it is also, again, cross-culture specific, in the sense that oftentimes students in our research in Japan, for instance, were underestimating their contributions to the group work, whereas in our research experience in the UK, students were overestimating their contributions to the work. But the lack of accuracy oftentimes is there, which brings me to the point about the value of these kind of analytics and AI approaches as a very powerful self-reflection, self-awareness tool.
Thank you. I'm aware of the time. However, the last question here is pretty good to, I think, finalize the session. So I'm going to push through it. I'm sorry, guys. If we want to use these technology in school in the future or near future or right now, we'll need a lot of preparation for ethical aspects that you have touched up a little bit on some, such as student consent. And what should we prepare? How should we prepare students and teachers for that kind of aspects when we try to introduce and operate this type of technology in the educational system?
So as I mentioned, I think maybe we can acknowledge a few issues with regards to this question on the ethics. First of all, we have done a recent systematic literature review looking at how much of the existing work is indeed looking at the ethics of multimodal learning analytics or multimodal AI applications in education. And we found very little there. So one thing to acknowledge is that there is a lot of work that needs to be done in terms of improving our understanding of how to implement these technologies ethically in real world setups. So that's one thing to acknowledge. Second thing that more specifically relates to consent is, to me, getting consent from students is not necessarily a very significant challenge, particularly due to power dynamics of a formal education system. But to me, getting consent is not really enough on its own unless we manage a genuinely informed consent, in the sense that do students who are consenting for these technologies to be used upon them understand the real implications of these technologies on their practice? And this requires the second group of work that I was trying to mention, in terms of educating people about AI on how to use them ethically effectively. I am, for instance, shocked in terms of the number of people who are engaging with large language models today, and the number of people who are aware of the limitations of these technologies and the potential ethical implications. To me, before these technologies, tools, models are ruled out to the real world, we should do a lot more thinking about what are the implications and impact of this scale of ruling out. And I think this is the case for the technologies that I have just presented here as well. We need to think very carefully in terms of long-term implications of these technologies before we roll them out. To me, what is happening currently, driven by the commercial interests of companies, is almost like a huge scale experiment that is happening to the society. And I'm not very happy about this, to be fair. And the last thing I wanted to very quickly say with regards to this question about the ethical implication is something that I just forgot. So I'll stop here.
Thank you so much. I think with that note, we can finish the second lecture and with the big round of applause. Thank you so much. 이상으로 서울대학교 2024년 제1회 학습과학연구소 심포지엄을 모두 마치겠습니다. 올해 학습과학연구소에서 또 다양한 세미나와 또 워크샵, 또 제2회 심포지엄까지 준비 중에 있으니까 여러분 앞으로도 관심 많이 기울여 주시고요. 또 궁금하신 거나 또 여러분이 만나고 싶은 연사가 있으면 언제든지 저희에게 또 인포메이션 주시면 저희가 준비하도록 하겠습니다.